In this lesson, we're going to explore how to add an emitter to one of our containers. Now, just as a general rule, I'm going to be working with lots of blank screens. That way, you can start really fresh right along with me, and you won't have to open up a scene file through this training. Now, what I'm going to do is go ahead and create a new container, and I'm going to do this quite often. Okay, there's our container, and what I'd like to do is add an emitter. So we'll go up to Fluid Effects, Add Edit Contents, and we'll choose Emitter. Now, doing this is just like if I went up here and said, create the container and the emitter. Just do it all in one shot. So you're welcome to do that from now on. I'm going to split things up that way you know exactly what I'm creating. Okay. Now, what we have here, again, is a 2D container. And we're going to start to go through some of the options that are available. Now, before I do that, you'll notice that I'm working with roughly 555 frames, and I just went into my preferences here, my animation preferences for my time slider, and I just set them to 555 in here. All right, let's go ahead and just play this back. Now, when you play it back, you're going to get something that either looks like this or looks like, let me just rewind it, that may be pink. There we go. So if you have something that looks like this, what we're looking at is the fluid emitter that is emitting fluids into our system, and we're looking at the wireframe version. Now, of course, we can't have a wireframe representation of the fluids, so it's represented by individual dots or particles. So to view the actual shaded version, just hit 6 on your keyboard, and that will bring up the shaded version of your container and the emitter that's emitting this out. Now, what we're looking at essentially is density inside of our system. Now, we can do a number of things. We can go ahead and move our emitter down. We can move it over if we want. And wherever we move it is where the particles will get emitted, so that's nice. And there's a number of things that define this container. Now, we briefly talked about it in the previous lesson, but really what we're looking at here is an empty container that has an emitter that has a certain resolution. Now, this resolution is where you're going to want to really focus your attention. If I set my resolution to something like 10 by 10 and then play the simulation, you'll notice how fast the simulation plays. However, it is really, really low quality. Okay? You can actually preview what that looks like by going down to the display folder, opening that up, and then right here where it says boundary draw, we're going to change this from outline to full. And now you can actually see the individual voxels that we were talking about earlier in a 2D container. Now, of course, if I set this higher to something like 50, let me rewind this, by 50, you'll notice I have now a tremendous amount of information. However, when I hit play, I get a little bit of a slower playback. Now I'm going to adjust this to something like 100. Where do we rewind this? By 100. Okay. And I'll go ahead and turn off where it says my boundary draw. I'll just take it back to outline. Okay, and we'll close this up. So you can tell that's a lot of information. However, when I play this, it's a little bit slower, but it's a lot more accurate. So the higher the resolution, the higher the accuracy of your actual fluid simulation. Now, the size is actually controlling this in outer boundary. You could scale it, but here's the problem. If I scale this in, look what happens to my simulation. It just gets stretched. Okay, that's not the same. So let me rewind this and undo. There we go. It doesn't like that. You could scale it. It's not a problem. It's just, you know, the setting on the node above it that's controlling it. But it's not the same as if I drop this in half. So if I said my size is actually 5 by 10, watch, as I play this back, it's not squished. It's an actual accurate representation of what's really happening. So something to really keep in mind. Now, my voxels are a little bit off-sided here. So I've got still a resolution of 100 by 100, but I only have half my width as opposed to my height. So if you really wanted to, you could drop that down to 50, and that would get you closer to a square. That would be a better representation, as you can see here. Okay. Now, let's talk about these boundaries, and then I'll save height field for a separate lesson. The boundaries are very, very important because right now, by using a boundary on both the x, positive and negative, and the y, positive and negative, we're saying essentially contain all of this fluid simulation. So once you hit the top, you hit the edge, this is a container. Now, if I go to my boundary y and I turn off, I set it to none, okay? We'll say no boundary. Watch what happens. When the fluid hits the top, it just disappears. Now, it lingers here, but it's essentially gone. So if we had a simulation that we know that it never wants to go outside of this boundary or look like it does, we can actually set this to both sides, okay? And now you'll notice that they just disappear. They don't bounce off the edges. Now, you do have control, so you don't have to use none. You could say, you know what? I don't want it to collide with anything on the negative x. Or I want it to collide with only the negative x. So it disappears here, but it collides over here. Okay, and you can do the opposite. And you can see how it lingered now as it's colliding with this edge. So there is a boundary system. It's pretty neat. The one thing I really want to show you about, I'll set the x to none. I'm going to set the y to wrapping. Now what happens is the particles or the fluid simulation, as it hits the top, gets repeated right down below. So you can kind of see it here, how it went up. Here's the tail end. Now, why would this be important? Well, this could be very, very useful for creating tileable textures if you're going to be using one of these fluid simulations as a texture map for something else, which you can actually do. So in the next lesson, we'll take a look at how to utilize the height field along with the depth that's contained inside of a 2D container.